Well. Welcome back. Happy Wednesday. A couple announcements here to begin with, and then we will get into something here for a few minutes. Number one, probably the most important thing I could say, and that is 24 hours from right now, we'll be staring at Friday. Think about that. I know. That's pretty novel. I know you've probably never heard that. So I wanted to share that. Hopefully that speeds your week up a little bit. Second of all, I know some of you are going to be really upset about this out there. I actually ordered a real whiteboard. So this Crayola version is going to go bye-bye here in a couple days. Hopefully it doesn't hurt you too much here, but that'll definitely give me more space to work with. Lastly, as you probably figured out, I put an announcement on there about this. I will be putting more assignments on as assignments rather than just putting something in the stream. I feel like if I keep putting things in the Google Classroom stream, at least that's what it's called on my end, it kind of gets lost in the shuffle, and I think it's easier to organize if it's an assignment. So I will probably do more and more things like that. It will not always be a Google form. In fact, tonight's assignment will not be a Google form. You'll find out here in a few minutes. But just wanted to kind of say that. Now, let me say one thing about the forms. When I do provide a Google form, for me, and I know maybe not every teacher's like this, but for me, it's easiest to have you, and I usually make this the very first question, I have you write your name in. I actually make that a question because when it shows up on my end, if I have everybody's name next to their responses, it just makes it a lot easier. So if you could do that for me, I know most of you are already doing it and a couple people forgot. Put your name there. It should be a question anyway, and that way I can see who you are. All right, so here's the deal. In the modified way we're doing things, this is probably going to be the last, I'll call it, new day of approximating area under the curve, because where we're headed next is not going to be about approximating, it's going to be about the actual exact area. And believe it or not, that's where the calculus side comes in. So that's where we're headed with this. I'm not sure if we'll do that tomorrow, if we'll do it Friday, but that'll be very soon. I think this will be our last kind of new day though of the rectangle stuff, okay? Now, what could I possibly do that's new? Here it is. You have hopefully the note sheet that goes with this that I attached for today. So you could actually print that out and kind of follow right along with me as I do this, or maybe you just have it on the screen and you want to take notes on the side. But you'll notice this is the first problem for today. And what's the difference? I didn't give a function. So hopefully you know by now to find the height of all these rectangles, you plug into the function, whether it's x squared or whatever it is. How do you get the heights if I don't give you a function and instead you have a table? It's pretty obvious. You don't need to plug anything in. You have the heights right here. All right. So in a lot of ways, when I give you a table of data, it's even easier because you don't have to really do as much algebra. All right. So this first problem is about a speedboat over the course of, looks like it's from the 6-second mark to the 12-second mark. And it gives different velocities. And I want to know, how far did that speedboat travel? Remember, the area under the curve is the total distance traveled when this is velocity, which it is. We're in feet per second, okay? So real quick, I went ahead and took the liberty of drawing this out ahead of time. It's just a sketch. You can go ahead and draw it as well. But really what it's about is base times height. And the base, of course, would be 1. And then you multiply by the heights. Now, this came up, I think, yesterday a little bit, and now here it is again. There is a difference between LRAM and RRAM in that when you're doing an LRAM problem, you actually count that very first point because it's a left endpoint, all right? And you don't count the very last point. But in our problem, because it's RRAM, you're actually not going to count the first point, and you are going to count the last point. You can see it right here. This first rectangle, what's the height of the rectangle? It's actually this point right here. It's not that first one, all right? It's this point here that hits the curve. So that's why we don't even use the 6. We don't even use this 42, okay? So here we go. A base of 1 times a height of, starting with that first right end point would be 58. And I think you can see where I'm going with this. Plus 68, plus 75, plus 80, plus 86, plus 88. And if you do all of that, of course, you end up with a total distance traveled of 455 feet. Okay? So you may, for homework tonight, have a problem or two like that. So I wanted to make sure that makes sense. I think it's pretty self-explanatory. Okay, I'm going to do number 2 on your note sheet as well with you, which actually is kind of a review of not today, but the last days prior to today. It's just an LRAM problem. All right. So if you take a look at number 2. Just kind of reading off the paper here, it says use 4 rectangles. It says our function is x squared. The interval is 3 to 4, and we need to do this by writing out our work as always. All right, so just a quick sketch again. We're dealing with x squared. We know by now what that looks like. This is not going to be to scale because I'm kind of out of space, so I'm going to make the 3 mark right here. And I'm going to make the 4 mark right there. And it says use 4 rectangles. So the first thing that I always do, let me kind of remind us up here, this is LRAM. First thing I always do is take that total width, 1 in this case, divided by how many rectangles it says to use. So obviously 1 divided by 4 means that each one is 0.25 wide. Now remember, to draw your picture accurately, you want to take your first rectangle and literally put the left end point on your graph and draw your rectangle from there. Okay? Next rectangle is right here. Draw that left end point in and then draw the rectangle kind of last. That's the easiest way to do it. Okay, and one more. There it is. Now notice, unlike number 1, we are going to use the value that goes with 3, but we're not going to use the value that goes with 4. That's not on the curve. So that's the difference between LRAM and RRAM. Anyway, base times height. So the base is going to be 0.25 or 1/4. And then you're going to plug in, to get the heights, you're going to plug in 3, 3.25, 3.5, and 3.75 into the x squared function. Obviously use your calculator for that. So I'll just kind of show that real quick here. When you plug in 3, you get 9. We all know that. When you plug in 3.25, you get 10.5625. When you plug in 3.5, you get 12.25. And finally, when you plug in, because I'm out of space on my little teeny board here, 14.0625. Okay? Add them all together and then multiply by 0.25. You end up with, rounded to the nearest hundredth, 11.47. Okay? So that's just a good review of what we did the day before, in case that didn't all make sense. Here's one more example for you. So a couple things here. We are going to take some kind of an assessment or quiz coming up in the next week or so, or week and a half. So I'm still thinking about that, brainstorming that, how I'm going to do it. You know, maybe it'll be some kind of a Google quiz or Google assignment. I haven't decided yet. But just keep that in mind. Keep up on your assignments. Keep doing them. Turn them in if I ask you to turn them in. And then hopefully by the time we're ready for our quiz, you're going to be ready for whatever comes your way. I'm probably going to give you a related rate problem here just to review that. That's been several weeks, and that is something I want you to still remember how to do. So I'll probably do something with that in the next day or two as well for practice. But for now, this is our topic for today. Now, here's what I want you to do tonight. I also attached, as you probably can see, worksheet 5.1 that goes with this. And what I want you to do is, again, either, probably the best option if you can, is to print that out. If you're not able to print that out, you don't have a printer, you don't have ink, then do it on a separate sheet of paper. Show your work, show your graphs, show your steps like this. And then what I want you to do is I want you to take a picture of it. Some of you have already been doing this, but take a picture of it and submit it in the Google assignment that I'm going to post there. All right, and I'll hopefully say all this again on that as well. But that's what I'd like you to do for homework tonight. One more time, either print it out, do the work on there, or do it on a separate sheet. But I am attaching the homework, which is worksheet 5.1. Take a picture when you're done of both sides or whatever is involved, and then submit it, attach it to the assignment that I'm going to put on Google. That'll be due Thursday morning, tomorrow morning at 8 a.m. All right? Keep up the good work, guys. I know this is probably kind of crazy balancing all your classes like this, and it doesn't help when we're a little unorganized ourselves, but hopefully it's starting to click for you, and we'll talk to you soon. Thanks.